Hi ladies, in this video we're going to go through the sine rule. So we're going to start looking at triangles that aren't right angle triangles. So when we're dealing with non-right angle triangles, we're basically using either the sine rule or the cosine rule. Don't get them mixed up with the sine ratio or the cos ratio. Okay, so it's a little bit different. We call them the sine rule and the cosine rule. So basically, when we're labeling our triangles, it's a bit different to when we were using trig ratios, so like SOHCAHTOA, where it was the opposite adjacent to hypotenuse. Now we just usually label them A, B, and C. So just to make things extra confusing, I know because in Pythagoras we label them A, B, and C, and then we do the trig ratios, and they're no longer A, B, and C, they're H, O, and A, but now sine rule, we're just labeling them A, B, and C. Now, when you're labeling your triangles, we always use capital letters for the angles. So you'll notice we've got capital A here, capital B here, capital C. Doesn't matter which ones you call A, B, and C, but you have to get their corresponding sides correct. So you can see here lowercase a is opposite angle A, lowercase b is opposite angle B, and lowercase c is opposite angle C. Okay, so basically the sine rule states that the ratios of each side of a triangle to the sine of the opposite angle are equal. Okay, so this is your sine rule, and the same thing, just flipped over. Okay, usually with the sine rule, we don't do all three, we just need two. So what I mean by that is, if we know angle A and side B and angle B, we just do A over sine A equals B over sine B. You don't need to include the C because you don't need that much information to find something. So I would write it like this. Always put your unknown first. So let's say if your unknown was side A, I write that first. Now, if your unknown was an angle, you write that angle first. So sine A over A equals sine B over B. Now, there's nothing wrong with not writing it first. It's just convention. So it's always easier to solve when your unknown is in your numerator than what it is on the denominator. But it's still going to work as long as you can do algebra okay. So you can see there, might always put your unknown first. Okay, now with, I'm not going to read all that. I'm going to go back to the ambiguous case of the sine rule. So what it means by the ambiguous case is you can sometimes have two possible angles, okay, two possible answers if you're looking for an angle. So what that means is if I look at this diagram here, okay, that I've just circled, you can have, if you were finding theta, you could have two possible values because this length here, actually I might highlight it, just because I like highlighting things. This side here is the same as this side. So I could effectively draw two triangles. Okay, I can draw this triangle on the outside, like that. Okay, and if I was using that triangle, I would still have this side 10 and this side, whoops, not that one, this side 6. And if I was doing this smaller triangle, I would still be using side 10 and 6. Okay, so that's why there's two possible answers. What you just need to know, it only applies to angles, not when you're finding two sides, but basically your two angles, I just noticed that that should be the number 1. Theta 1 and theta 2 equal, oh no, sorry, that's me not reading the question the equation properly. So they're supplementary. So that means they have to add up to 180. So theta 2, your second angle, is just 180 minus the other angle. Okay, so they have to add up to 180. So I didn't really read the dot point before I started talking before. Okay, so question 2, when you're doing the sine rule, label your triangle first. So just like when you do Pythagoras, when you're using the trig ratios, always label your triangle. As I said before, it doesn't matter the order of A, B, and C, as long as you get your opposite sides correct. So here I've got angle A, so this is A. angle B, so this is going to be B, and then angle C, C. Now, I don't have much room here, so I might just make this a bit smaller and write down the bottom and just make it. There we go. Okay, so A, B, C, just identify what you know. Makes things so much easier. Some people are quite visual and can just do it straight from a triangle, but if we do it like this, it just means we're less prone to make any mistakes. Okay, 84. C hasn't been given to us, so I'll cross that out. Little b is 10, and we don't have a little c. So when I'm using the sine rule, I'm going to be using or writing a and b. So remember, always put your unknown first. So it's going to be little a over sine a equals little b over sine b. So I have to be consistent. If I've got my lowercase letters on the numerator, both have to be on the numerator. If they're on the denominator, they have to be on the denominator. Now, if you're wondering why I wrote a over sine a, because that's your sine rule here. Okay, I'm just copying that down. I've done trigonometry for a very long time, so I remember it, but always, go back if you're a bit unsure. So now I do my substitution. So A is labelled as X, so I'll just put X there, over sine angle at A is 52. B is 10, and sine B, so sine 84. And then we're just solving for X. So I'm just going to scroll down. Now, to get X by itself, I just need to get rid of sine 52 on the denominator. So to get rid of any denominator, I just multiply. So times sine 52 times sine 52. Oopsies. Okay, so we've got X equals, on the numerator, 10 sine 52 over sine 84. Now, when you're putting that in your calculator, okay, so 10 sine, put it in brackets, 52 divided by sine 84. Press enter. You can always, the good thing about CAS calculator is it's written there for you, so just make sure it looks the same. So 7.92. I can't remember what we're working in. Let's just scroll up. Centimeters. Okay, so just one thing to remember, your biggest side should be your biggest angle. So there's 84. So 52 is here. That means X has to be less than 10 because 84 is bigger. You can always work out C as well. So I can work out that angle there because all the angles inside a triangle add up to 180, but we don't have to do that just yet. All right, I'm going to do another one. So let's do E just so I can see it while I'm writing. All right, so the first thing, label your triangle. So it doesn't matter what you label A, B, C. Okay. So then just rewriting it. You might think, oh, so much rewriting. Why doesn't she just go straight to the question? It's up to you. I think it's better to make sure you get things down correctly, and we don't need the C's. So I'm going to be using A and B just like before, but I could have been using B and C or A and C. Just all depends on how I labelled my triangle. So A over sine A. So remember, I'm putting my unknown first. So my unknown is lowercase a. Keep consistent with your lowercase and your uppercase letters. So my lowercases are on the numerator. So X over sine 40. B is 12 over sine 67. Okay, going to multiply both sides by sine 40. So times sine 40 times sine 40 goes away. X equals 12 sine 40 over sine 67. And then you can put that in your calculator, I'm sure. Okay, let's look at F. Now, this time I'll do one where I don't label A, B, and C the same way. So let's call this C. That'll just make that C. And I'll call this one B. B and A and A. Okay, so A, don't have, and lowercase a, I don't have. B is 110, little b is 30.2, and big C is 45, and little c is x. So when I'm writing my sine rule, remember you always write your unknown first. So little c was my unknown. And I've got my b, so that's why I'm using b. So, look at me trying to be consistent with my colours. X over sine 45, 30.2 over sine 110. And then you can kind of get the gist because everything's pretty much the same. So that sine 45 comes over the top here. Over sine 110. Okay, so next question I just put in because this is looking at, what am I talking about? The ambiguous case of the sine rule. So it does say if theta is acute. So remember an acute angle is less than 90 degrees and an obtuse angle is greater than. So what we have here is this 100, oops, sorry, if theta was, oh, okay, oh, all right. I was just thinking of something else, but that's okay. So it's telling us if theta is acute. So it just means that our answer has to be less than 90 degrees. What I might do is I might just do 1, and I'll scroll down. I'll do D, just to show you what the two possible answers are. Okay, so I'm so used to labeling my unknown as A, B, C, but it doesn't really matter. A. It's actually pretty good to do this question because this time we're solving for an unknown angle. All right, so again, labeling what you have or knowing what you have. So angle A is theta, little a is 20, angle B is 78, little b is 28, and we don't need the c's. So if I'm writing down my sine rule, remember we write the unknown first. So in the previous question, our unknown was a sine. This time our unknown is an angle. So when your unknown is an angle, we put the angle first. So sine A over little a, and then sine B over little b. Okay, so it just makes it easier to solve. There's nothing wrong with if you did little a first. It just means more algebra for you. Okay, so sine theta over little a, which is 20. Sine, already put the angle in. Didn't mean to do that, 28. I should have written B there, but it's all good. I'm sure you understood what I did. All right, so we've got sine theta equals 20 sine 78 over 28. Just going to make sure I've written that down correctly. Cool. All right, now we want theta by itself. So remember when we did the trig ratios, we did inverse sine of both sides? Same thing here. Now just put all this in a bracket though, otherwise you're going to get the wrong answer. Okay, so on our calculator, so inverse sine, trig, inverse sine, 20 sine 78 divided by 28. So 44.32. So that's the acute angle. Now, if you wanted to get the obtuse angle, it's 180 minus 44.32. So 180 minus, just scroll up, get that, and then we go 135.68. Okay, so Usually most of them will give you the acute angle, but if not, you can just get it from the obtuse one. And I think later on in the topic, you have to do an obtuse angle. So you just do exactly what I've done there, and you just take that acute angle away from 180 to get your obtuse angle. All right, ladies, let me know if you get stuck on any questions, but sine rule, not too difficult. Just make sure you label your triangles properly. Bye.